number 412. How accurate is a Riemann sum? We're going to use the integration feature on your graphing calculator to calculate the integrals. So we want to go into y1 and put in our function. Now we know what that function is going to look like. We could graph it from negative pi to pi over 2. And that b value of 2 makes it have a period of pi. So we should have a full period at negative pi. And then by pi over 2, we should be halfway back. So that's what we want our graph to look like. And then we want to calculate the integrals. So once we've got that in y1, we're going to go second calculate, which is right above trace. And down on number 7 is our integral button. So we're just going to press 7, and it says lower limit. And you just type in, negative pi instead of like 3.14. And then press enter. And then the upper limit we want to be pi over 2, so I'll just type in pi over 2. And it'll actually shade it in for us, so we know we're right. It's calculating all this. And it says the integral there is 3. So then we can ask the question, if that area is 3, would it have been any different? What if I would have went from negative pi to 0? What if I would have went from just 0 to pi over 2? All kinds of questions we could be asking. All right, let's take a look at the next one. The integral from negative 5 to 5 of x squared minus 3. And that should look like some kind of a parabola. At negative 5, it should be at like 22. It should be way up here, just by symmetry. All right, so let's go ahead and graph that. As we integrate, we should see some area here. Now remember, I definitely don't have this to scale, do I? But the important concept that we're learning is area is bound by a curve and the x-axis. So we second calculate it from negative 5 to 5, and we should get the number 53.3. So that means there was more positive area up here than there was negative area here, wasn't there? So definitely not to scale. Good.